Callback methods have associated issues that result in a messy code structure, difficult to debug and unmanageable source code. To understand why this happens, we have to understand some associated concepts like nested callbacks and callback hells. Let's start with a very simple example and try to understand these issues with the help of figures and code examples.
We have two functions here. Data fetching function will talk to the database and try to fetch the data. Data receiving function is passed as parameter to data fetching function, and when the data will be received from the database, a callback will be made to data receiving function to pass the data to the main code execution thread. Let's understand this with the help of a diagram. Our main code is executing and it makes a call to a function that fetches data from the database hosted on a cloud server. Let's call this function data fetching function. When the data is being fetched from the database, our main code execution continues to execute other parts of the code. And the data fetching function makes a call to the database and receives data back. Data fetching function makes use of the callback function which was passed to it as a parameter and calls it to pass data to the main execution thread where data can be utilized in some form. For example, we can show the data to the user by updating the HTML.
However, this is a happy scenario only. What if the call to the database fails? There might be a network problem or the database server might be down for some reason. Ideally, the data fetching function should wait for some time, and if it does not get a response, it should send an error message to the main execution thread using the same callback function. In case of failure to load the data, how to modify the callback to pass the information regarding the failure? One solution could be to pass a flag along in the callback function. Success flag in the data receiving function will tell if the data in the second parameter is valid. We can have a simple if condition to check if the data was retrieved or an error occurred. If success flag is true, we have data in the second parameter. If success flag is false, we are sure that some error has occurred and data is not provided. If we want to pass the error message as well, we can define third parameter in the callback function. If success flag contains false, the error message is available in the third parameter. The if conditions and callbacks are fine if we have smaller code. But as the code grows, we might need lots of callbacks, and error propagation in the entire code can become a tedious task. Also, the readability and maintenance of code becomes time-consuming and error-prone. Imagine you have to make another call to the database when you have received data from the first call. If you follow the same coding pattern, you might need another two functions and if conditions as we did before. In real-world applications, you might need many nested calls which will lead to callback hell. For example, if you want to view a post of your friend on Facebook, you might need calls that will first log in you, fetch your friends, get ID of your desired friend, find posts of the desired friend, and get details of the post. All of these calls will require you to make nested calls and callbacks in the code, which will lead to messy code and will require managing happy paths and errors tediously. This pattern of nested calls is called callback hell. To solve this issue, modern JavaScript has a clean way to code. Here comes the concept of promises. Promises provide a more structured and readable way to work with asynchronous code compared to traditional callback-based approaches. We will learn and explore promises in our next video. You can find the link to the next video in the description of this video. Hope you liked the content. Please like, subscribe, and hit the bell icon to support our channel. Thanks for being part of our journey.